Oleg will tell us more about matching domain. Oleg is one of our old-timers. He's been around at Vinted for almost 9 years. So if you'll have some questions that us fairly newbies can't answer, then Oleg will.
Yeah, hello everyone. I'm Oleg. I'm a staff engineer at the matching domain. And let's start off with what matching domain does. So essentially, and this is where the name matching comes from, is that we match buyers to sellers. And on our platform, you can upload your clothing or other items you want to sell, and thus you create listings. So sellers create listings, and we need to find buyers for those listings, making both sellers and buyers successful. And in the whole flow, you can imagine like matching comes right before the transactional experience, before Gedus's domain. So how do we do that exactly? So we, as a domain, own a bunch of product features that allow us to achieve exactly that, matching buyers and sellers. So here you can see a bunch of screenshots, and at the top you can see our search bar where you can type something in and find something to buy, for example. So this is search. Then next up we have the recommended listings block. So basically you can find, like without prompting, without typing anything in, we might decide that you might like something, and therefore we can show it to you. Next up, we have favorites. And in this next screenshot, you can see this heart symbol, which takes you to your favorites. And then next up, we have our category tree, which is a part of our, we call like metadata system. And also matching owns parts of the infrastructure, which is meant to support all the other features, for example, like search. So before we go into the technical details, I want to show you the structure of the domain itself. So in our domain, we have 5 subdomains. It's search, ontology, discovery, matching platform, and item retrieval and ranking. So in simple terms, you can think of subdomains as teams, but they're not exactly teams. But for simplicity, just assume they are. So I wanted to show you a bunch of product features we own and work on as examples of what you might expect if you, for example, as a backend engineer, you joined Vinted and matching in particular, and what you might be working on. So first up is search, and this is the high-level search architecture diagram I came up with. So at the left, you can see the web app. It's called Core. It's our biggest monolith. It's written in Ruby, and it uses Rails. So this is not up to scale in terms of the number of lines of code, of course. So like the Ruby monolith is the biggest one by far. And on the left, you can also see our primary data store, MySQL, and it's our primary like source of truth for almost anything that happens on the platform. So for search purposes, MySQL is not that great. So we use Elasticsearch, which is here on the right, to perform actual search. And in this case, we have to make sure the state in MySQL and Elasticsearch is kept in sync. And we achieve that by implementing this indexing pipeline, which is in the middle at the top. So the idea here is that whenever something happens to a listing, for example, it gets created, deleted, or updated, we publish a message in a Kafka topic, and the indexing pipeline listens to those events. This is done in Flink in particular. And we also use Redis as this temporary storage to come up with the final representation of each listing. So like every message could have a part of the listings data, and we need to come up with the final representation of an item, of like a listing. And then afterwards, we flush that data into Elasticsearch. On the querying side, we have the search service written in Rust. And its main purpose is to shield like web app from the complexity of querying Elastic. It basically provides a simple API for the web app to use. For example, the web app might send requests to the search service asking for listings from some particular category with having some particular size. So the search service would get a request with that data and convert that to Elasticsearch query. And as you might know, Elasticsearch query is this JSON DSL, so it's quite complicated. In this case, like search service takes care of all of that. So it then collects the response from Elastic and forwards that back to the web app. So one of the main challenges with search is the scale challenge, and to demonstrate the scale, like currently we have over 900 million listings, and imagine we change something about its representation, and something that change needed to be replicated in Elasticsearch. So imagine we have to do something with every listing on our platform. So if we take just 10 milliseconds per listing, it would take us 105 days to go through all the listings. So we need to be really smart of how we approach this, and currently it takes way less than this. So, but basically, like to demonstrate the scale we're operating in, like that's the way. So next up, we have re-ranking, and here's a structure diagram for re-ranking. So in the previous diagram, we had web app, search service, and Elastic. These are the same ones as before. And we also can see here re-ranker service. So the results from the search service are not shown as is on our platform. Before we show the results, we send those results into the re-ranker service, which has a purpose of rearranging the order of items of like those listings in order to show you the most relevant, the best content first. This service is written in Python because it's the obvious choice for machine learning projects. And at the core of this re-ranker service, there is a machine learning model. And as a backend engineer, you're not expected to know the details of the machine learning model, but you work on all the rest. So which means like wrapping the model into a service, maintaining the service, taking care of logs, taking care of scaling issues, creating like this client on the web app side and querying the re-ranker service, and then so on. And the machine learning model itself is built by data scientists, which also work along with you in your subdomain if you work on re-ranking. Next up, we have homepage. And homepage is the first page you see if you open our website. And also, it also exists on our app. And if you're logged in, that's the first page you see. So in this case, like MySQL web app and the search service is the same one as before. Recommender service is very similar to the re-ranker service, but it's a different instance of very similar code base. But its purpose is not to rearrange items, but it's more to suggest you specific like things to buy, for example. So on the homepage, we have a couple of different blocks, and each one has some data source it queries, and it shows, for example, that one of the top for you is probably the recommended items. So it might query then the recommender service and show you the results from there. And also some of the blocks just use like the search. For example, if you've bought a particular brand, we might show you more items from that brand. And also at the very bottom of it, we have feed, which uses Redis as the primary store, and it just shows you items that have been like recently uploaded. Next up, we have the metadata system, and the metadata system is basically the system of assigning data to our every listing. For example, on the left, you can see this is the screenshot of our website where it shows you the category tree. And every listing is assigned a category. So we need to have a system of like what the categories are, what should be in every category, what the category tree looks like, and then so on. And on the right, you can see a part of our item page, and you can see brand size, condition, and color there. And this is also a part of our metadata system, which allows us to basically classify in different ways what content we have on the platform. So we have a subdomain which works on the metadata system, and as backenders, you work on like the technical implementation of providing the data, saving the data, and so on. So next up, we have Vespa, and one subdomain which was created fairly recently is matching platform, and their main purpose right now is to investigate Vespa as an alternative to Elasticsearch. And this is done so that perhaps we can combine the re-ranker service and Elastic all in one, because Vespa can run similar machine learning models as we run in re-ranker service, but inside of the data service, the data store perhaps. So we could simplify this architecture diagram to having just Vespa, for example. So we have the whole subdomain dedicated to trying it out and seeing if it works for us, and seeing if it brings any benefits to actually having Vespa instead of Elasticsearch. So that's it. Thank you.